This video, we're going to talk about 5.1 Objective 3, where we determine if variables are normally distributed. Let's first consider the following distributions and ask which distribution is not normal. So that would be B because it's skewed. It's not symmetric. Of the two normal distributions, A and C that are left, which has the larger standard deviation? And that's C because it's more spread out. The larger the standard deviation, the more spread out the data is. Determine whether the following data set is likely to be normally distributed. Explain your reasoning, the amounts of rainfall in inches on each day of the year in Detroit. That's not very likely to be normally distributed. So there will be many days with 0 inches of rain and very few days with large amounts of rain. There will be a peak in the distribution to the extreme left. So now state whether one would expect the data set described below to be normally distributed and explain why or why not. The eye colors of all adults in the United States. And you would not expect this data to be normally distributed. This is B. Such data are nominal, meaning that it's just words and not, there's no numerical value to it, and therefore cannot have a symmetric distribution around a mean. So determine whether the following data set is likely to be normally distributed and explain the reasoning. The pulse rates of randomly selected adult females. That would be likely to be normally distributed. The pulse rates vary above and below the mean by similar amounts. Distribution has one peak and is symmetric. Pulse rates result from combinations of many factors. So determine whether the following data set is likely to be normally distributed and explain reasoning. The measured systolic blood pressure of randomly selected adult females. And again, this is likely to be normally distributed. Systolic blood pressure levels vary above and below the mean by similar amounts. The distribution has one peak and is symmetric. Systolic blood pressure results from many factors. Number 6, state with an explanation whether you would expect the following data set to be normally distributed. The digits in randomly selected telephone numbers. You would not expect that to be normally distributed. So of the telephone numbers randomly selected, there could be more digits greater than 5 or more less than 5, which would skew the distribution. And state whether and why or why not you would expect the following data to be normally distributed. The exact amount of oil sold in 1 quart cans. Data set is expected to be normally distributed. It'd be unreasonable to expect all the cans to have exactly 1 quart. Instead, the amounts of oil will typically vary slightly, with values above and below the mean being about equally common, so that the distribution has one peak and is symmetric. And let's keep going here. We're going to look at this histogram now. The figure to the right shows a histogram for the body temperature in degrees Fahrenheit of a sample of 496 adults. And this distribution close to normal? And for a population of all adults, should body temperature have a normal distribution, why or why not. So this looks fairly symmetric. It looks like it has a single peak that looks like it's both the mean and the median and the mode that happens most often. So it looks like it meets the criteria for being a normal distribution. So the histogram is symmetric around a single peak and bell-shaped, so the distribution is close to normal. Yeah. For the population of all adults, should the body temperature have a normal distribution? Why or why not? Yes, because body temperature is a human trait determined by many genetic and environmental factors. The values for this variable should cluster near the mean and become less common farther away from the mean, giving the distribution a bell shape. So that's C. And let's look here now at number 10. The accompanying histogram shows the voter turnout as a percentage of 201 towns in a certain region. Is the distribution close to normal? And should this variable have a normal distribution? Why or why not? So just looking at it, it looks symmetric, bell-shaped. Looks like the mean, median, and mode are all the same. So it is close to normal since it is bell-shaped, symmetric, about a single mode there. And we would expect that the variable should have a normal distribution since the variable can be expected to have many values near the center of the distribution and be symmetric. Right? And that is it for this video. We will come back next time and we will talk about 5.1 Objective 4. See you for the next video.